Okay, hi everyone. So I'm going to give you a new video for doing bivariate statistics and presenting them for your particular research. Okay, so first let's review some of the concepts. So of course, when we say inferential statistic is the estimation of parameters and testing statistical hypothesis. So basically, when we want to examine the relationship between two or more variables, then we're using inferential stats. And then, of course, in our hypothesis, usually our hypothesis is trying to determine whether variable A and variable B are related to each other. So that's also the tool that we use, inferential statistics. Now, another typology of statistics is whether it's a univariate or bivariate or multivariable statistics. So for univariate statistics, it is the tests that we use to summarize only one variable at a time. So usually this is the descriptive statistics, right? So our goal here is to be able to describe the level, the magnitude, the central tendency, and the dispersion of a particular variable in a given sample. All right. And then we have the bivariate, which we will be tackling for today. It is basically one test compares two variables at a time, not more than two variables. So this is kind of the gateway to inferential statistics. And then there's certain statistics like regression modeling that takes in more independent variables or more dependent variables than one, and then relating it to one or more dependent variables, and we call them multivariate or multivariable statistics. And basically they kind of compare and relate to or more variables. So that's very important. And then let's review. In our statistics class, we kind of discussed on how do we identify whether or not we're going to use parametric tests or non-parametric tests. And really, the most important thing here is that parametric tests must assume normal distribution or a bell curve. And how do we test for normality of distribution? So usually, we test for skewness and kurtosis. So if the skewness and the kurtosis is less than the absolute value of 2, then usually we can say that they are normal. And then we can also use Shapiro-Wilk test. If the p-value for Shapiro-Wilk test is less than 0.001, then we cannot use a parametric test. Also the same for Kolmogorov-Smirnov. So the difference is for Shapiro-Wilk, this is for respondents that are 50 respondents or less, and then for Kolmogorov-Smirnov, this is for more than 50 respondents. We can also make use of Levin's test for equality of variance, which is a part of when we are doing t-tests or comparison of two samples or two groups of samples. Or usually, we can assume that when you have a large random representative sample in your recruitment, then you can already assume that your distribution is normal, and then you can already do parametric tests. So now, what is the parametric tests that why do we want parametric tests if we are doing research? Is because it has more insights, it can draw more conclusions, it's a little more preferred in the statistical world compared to non-parametric. But for non-parametric, since it can grapple with non-normally distributed values in a given population, then it's more feasible or it's more flexible. But more valued or more respected in the statistical world is your parametric. However, particularly for our department, when we talk about statistics, it's very important that we have to look at our sampling technique or our recruitment. If our recruitment is convenience, usually the stance of the department is that we have to use non-parametric tests, because if it's convenience, then it's hard to ascertain representativeness. Although when you go to research, when you go to research articles, you'll be able to see that Some of them use large convenient samples and still go and do parametric tests. But just so you know, when you do your thesis and your thesis is quantitative, usually we go do non-parametric tests. So what I'll be doing here is that I'll be demonstrating both parametric tests and non-parametric tests as done in your JAMOVI. All right, so what are the common things, no, that we have to identify, or what are important when you look at inferential statistics? Then we have to set up the level of significance. So usually the level of significance will tell us whether or not the relationship we see between two or more variables is significant or not, and that we cannot just attribute these distributions or integrations or correlations by chance. Okay, so and usually in the social sciences, we use 0.05. So this is the main thing, no? For all tests, the first thing that we look at is the p-value. So if the p-value is less than 5, then we reject the null hypothesis, then we say that it is significant. And then if the p-value is equal to or greater than 0.05, then we fail to reject the null hypothesis, and therefore it is not significant. So just to take note that this phrase is very important, because we do not accept null hypothesis. We usually fail to reject or do not reject the null hypothesis, or the evidence is not sufficient to reject the null hypothesis, but we never accept null hypothesis. So that's very important. Although when we articulate our results, usually we kind of go directly to, what are the relationships that we see, what is the nature of the relationships, what is the magnitude of those relationships. And then also in the department, there's kind of conversations around when do we use a correlation, when do we use, related, just related, or when do we use the term associated. So usually, related is kind of the safest term that you use, because it goes for any form of variable, right? Whether that's categorical variable or ordinal variable or continuous variable, relationships can be associated. Although when you go to a different school, when your independent variable is categorical, you say no, it's not relation. It's not relationship. It's difference. But for our department and in the social sciences, we can actually say that they're related. When independent variable and the dependent variable are both continuous, they're either interval or ratio, then we can probably say they're correlated. However, since we are using non-parametric tests for our usual practice in the department, usually the safest term could be related or associated, so we can use either of the terms. There are some panel members who would say na they would like to hear the word associated because it's kind of a safer word to say when you use non-parametric tests. So yeah, so you consult with your mentor regarding what would be the best term to use. In my case, no, I'm going to teach you to use the word associated. Okay, so again, my personal stance is that when you have a large sample like the one that I'm going to show you, this one has 1,087 samples for this data set. This is an actual data set that I and some of graduate students generated for a string of research publications that we did. We what do you call this? We used parametric, because we coming from the assumptions that once it's large, central tendency theorem, we can assume normality, and also we tested Kolmogorov-Smirnov, and Kolmogorov-Smirnov was okay. However, again, I'm going to teach you for safety for your thesis. We're going to use non-parametric for safety purposes. Okay. So just a very brief discussion of our statistics class. When do we say that we're going to use Pearson R or Spearman-Rho? You can always go back to the previous YouTube videos, but just to really quick review, if the independent variable and the dependent variable are both continuous, then for parametric we use Pearson R, and then for non-parametric we use Spearman-Rho. and then the value or the statistic that we generate aside from the p-value is the r value. If your IV is nominal and dichotomous, when we say dichotomous, the answer is only, the levels are only two, like for example, gender or sex assigned at birth, male versus female, and then your dependent variable is continuous, then for parametric use an independent test, and then for non-parametric test, you use Mann-Whitney U test. For independent t-test, you will be getting the t-value, and you can also be able to look at mean differences to see whether or not which of the categories has a higher mean or a lower mean if the p-value is less than 0.05. And then for Mann-Whitney U test, we of course get the U value. All right. So if your value or your independent variable is nominal or ordinal of 3 groups or more, then like for example, civil status or educational attainment, and then your dependent variable is continuous, we make use of the one-way analysis of variance for parametric test, and then it generates an F value, and then usually for ANOVA, we have to do a post hoc analysis if the p-value means that we have to reject the null hypothesis. But if it's not, no need to do post hoc analysis. For Kruskal-Wallis, we use the x squared value. And of course, if it's the p-value is less than 0.05, we also do a post hoc analysis to be able to investigate which among the groups, or which, if you look at the patterns, which among these groups have lower or higher scores in terms of continuous variable. This one, we rarely use them in the department, but I'm teaching you also anyway. When there is a within groups or a paired nominal two groups, like for example, before and after, like for example, the question is when you're doing an experiment is what is the difference in the subjective well-being of clients before and after Zumba engagement. So you're talking about the same group of people, but you are measuring their subjective well-being before and after Zumba engagement. So same group, two different observations. So that's paired, or a within group are repeated measures. A repeated measure. So we use an dependent or a paired t-test. It also generates a t-value. If it's non-parametric, then we use Wilcoxon sign test. Now, if the number of observations is more than 2, like for example, before Zumba, 1 week after Zumba, 2 weeks after Zumba, 1 month after Zumba, same group within groups analysis, then we make use of repeated measures ANOVA. And then we also generate an F value and do a post hoc analysis. And then for the non-parametric, we make use of the Friedman's test, and then we also do a post hoc analysis. Now, this is done when at least one of the two variables is continuous. But what if the two variables in question are not continuous? Like for example, you have your independent variable is a nominal or an ordinal data, and your dependent variable is also a nominal or ordinal data. For example, is there significant association between exposure to formal swimming lessons and obesity in childhood or in adulthood? So exposure to swimming lessons, the answer is yes or no. So that's 2 categories. For obesity, obese or not obese. So usually, since there are no continuous variables in question, we cannot use, if you remember this here, no? Usually, there should be ratio or interval variable or continuous variable in order for you to do a parametric. So since there are no continuous variables, we cannot use there's no parametric. We go to chi-square. And chi-square is kind of a universal test that we use if we fail most of our assumptions for parametric tests. So yeah, chi-square. All right. Sige, so let's go and give an example. So for example, my colleagues and I, or my graduate students and I, were able to publish a paper in relation to is social media competence related to social media political participation. So social media competence basically is operationally defined as students, having the following skills, no? Do they have technical usability, or do they know how to operate a social media account? Content interpretation, are they able to interpret the content that they digest or they consume online. Content generation is that, can they generate content? And anticipatory reflection is more of, do they think about or do they reflect before they post or comment on social media? So these are the four, and this is based on the work of Zhu et al. In 2020 or 2019, I think. No, so it's a standardized questionnaire. So that's social media competence. So the first hypothesis question is there a significant relationship between background characteristics and social media competence? So for this study, or for this particular example, we'll use the following. We'll use the following background characteristics. So again, your background characteristics is the independent variable, and the social media competence is the dependent variable. So the table that you're seeing right now is something that you will do in your thesis. No, you have to do a table like this, identifying what the IV is, what the DV is, and then also identifying the nature of the variable, and then identifying what test you're going to use. All right. So, for example, these are my IV. So you have age, sex assigned at birth, income level, number of gadgets, number of active social media accounts. So these are. So again, what you do have to do first is to identify what type of variable they are in terms of scales of measurement. So age is continuous and its ratio. Sex assigned at birth is nominal and dichotomous, meaning it only has two categories. Income level is ordinal and multichotomous, or like more than 3 groups. So particularly we used here the 7 groups of NEDA. And then for number of gadgets owned, we just asked them what are the gadgets that you own, and then we counted how many gadgets they had. So it's continuous and ratio. For number of active social media accounts, it's also continuous and ratio. We asked them which social media are you on, and then we counted their yeses. So that is your ratio. And then since these are Likert scales, this 4, we use they are continuous and interval. So for age and social media competence, we use Pearson R for parametric and Spearman-Rowe for parametric. And this goes the same for number of gadgets owned and number of active social media accounts, because these are all continuous to continuous. So Pearson R, Spearman-Rowe. Spearman-Rowe if it is non-parametric. And then for sex assigned at birth and to dichotomous to interval, which is the social media competence, we make use of independent test, or if we're doing a non-parametric, we're using Mann, Whitney, U. For income level, we have it's ordinal multichotomous, so it's 7 categories versus in the interval data, so we're using one-way, ANOVA, or Kruskal-Wallis for non-parametric. So the next question is there a significant relationship between social media competence, or SMC, and social media political participation, or SMPP? So basically, social media political participation is the extent to which the students in this study engage in any form of political participation using social media. And so the social media competence, they use the 4 components, and for social media political participation, it also has 4 domains. So we have like latent engagement, if you are reading political posts or any advocacy posts. Counter engagement, if you use, abrasive behavior online in the name of political participation. Follower engagement, if you actively follow accounts or events or activities in social media related to political participation. And then expressive engagement is that you are actually posting or contributing to conversations around political participation of a particular topic. So in here, our topic of interest is gender, but since this is an example, I will not give like a very long explanation on that. So we have technical usability. So we had this. both are intervals, so we're going to use Pearson R or Spearman-Rowe for non-parametric. These two questions do not have chi-square, so I'll just give an example for a sample of chi-square later. So for example, for independent, we have sex assigned at birth, so it's dichotomous, male or female, and then whether risk for depression. So depression, yes or no, dichotomous. Since there's no continuous variable, we're going to use chi-square. But this is outside, the research questions. I'm just showing this to you for purposes of practice. Because some of you may need to do some chi-square work because of the nature of the variables that you have chosen for your particular studies. Right. So you will remember that this is the example that I gave you in your stats. So you can use this example when you present your APA for each, no? But for this particular example, I will give you another way of presenting that may be less stressful than this one. Okay, so there. Okay, so let's look at so I'm now moving to the JAMOVI part, no? So here is the JAMOVI. So here are the variables. So yan. So we have age, sex, income ID, number of gadgets, number of active social media accounts, so sites, technical usability, content interpretation, content generation, anticipatory reflection, latent engagement, counter follower, and expressive engagement. And maybe I can just put here the depression, right? So let's see here. Yeah, depression. So depression risk, yes, no. Okay. So all of them, 1,087. All right. So this is the data that we have. Okay. So let's do first age and technical usability. Or usually what we do is we put together all of the Pearson R. So if we can put all of the Pearson R together, all right, or the Spearman-Rowe together in one test so that we don't have to duplicate our efforts. So in this case, we're going to correlate age, number of gadgets, number of active social media accounts with this 4. Okay, so let's do that. So we go to regression and we choose correlation matrix, and then we include the variables that we want. So we place here first age, and then we place here number of gadgets and the number of sites. And then we include the 4. All right. And then you can click this flag significant correlation so you can already see which are related to each other. Okay. So the automatic or the standard or the default type of correlation coefficient that you will get is Pearson R. So again, you can use Pearson R if you can assume parametric test. So what you will be looking out for is the p-value. You have to look first for the intersections of the variables that you want to examine. So you wanted to see whether or not age, number of gadgets, and number of social media sites used are correlated with technical usability, content interpretation, content generation, and anticipatory reflection. And then what you look at first, usually what you look at first is number 1, you look at the p-value or look at the asterisk. If p-value is less than 0.05, then reject null hypothesis. And so we reject null hypothesis, and though there is a significant correlation, right? Okay, so you have that now. Okay, so that's the first step. So the good thing here is that for Pearson R and Spearman-Rowe correlation test here in JAMOVI, you can already examine that by looking at the asterisk. So you can see here that for age and the 4, there are no asterisks. So there's no bothering questioning the p-value because look at the p-values, it's higher than 0.05. But when you look at the intersections of gadgets and social media on the 4 components of social media competence, you see that they are all significantly correlated. All right. And when you look at the p-value, it's actually less than 0.001. So it means that there is less than 0.0, there's less than 0.1% that this is that what we're seeing is a by chance. No, they are really significantly correlated, meaning that in a way, no, your independent variable is influenced by the dependent variable, right? Not really caused, but they seem to have a pattern together. All right. Okay, so the next thing that you do after, the p-value is seen, for those that are significant, investigate the R value. The R value is the Pearson R. And then interpret two things. One, more importantly, the direction. And then number two, you interpret the magnitude. So in our department, how do we interpret that? So we use this. If you look at the document in the left, we use the work of Dancy and Raidi. This is the APA style no, not really APA style, but this is the reference. You can probably look at this. And if it's positive, it means that when the independent value is up, the dependent variable also goes up. And when the dependent variable goes down, the independent variable also goes down. Or if it's negative, it means that when the independent variable goes up, the dependent variable goes down, and vice versa. So it's an indirect relationship. Okay, so if we investigate here, using Pearson R, we can see that all of the signs are positive. All right, so since all of them are positive, then we are saying that the more gadgets and the more social media sites, the more likely that they are social media competent, because the direction goes the same for all of the components of social media competence. And then sometimes we don't have to report anymore, but we can usually interpret the magnitude. So the magnitude is, if it's 1, it's perfect. If it's 0.7 to 0.9, it's strong. If it's 0.4 to 0.6, it's moderate. If it's 0.1 to 0.3, it's weak. So for example, in this case, it's 0.225, so it's weak. 1.68, weak. 1.144, weak. 116, weak. So I think everything is weak. All right. So weak sila lahat. But significant. Weak, but significant. So usually we just say the direction. It's positively significant. But we don't have to really just always say it's positive. We can already make the inference in the paper. So when we can say that high levels of technical usability is linked to or is associated with high levels of or is seen among students with higher number of gadgets and higher number of social media sites. Okay, so that's how we interpret it. All right, so we now again in your study, in the study that you're going to do in our class, we're going to use non-parametric. Why? Because all of us made use of convenient sampling, and some of you really didn't reach a good enough sample size. So I think it's safe for us to use a Spearman rule. So we can click Spearman rule. And basically, the process is the same, So you investigate the p-value, and then you look at the R value for those that are significant, and then you interpret using the same tool here. Okay, so therefore, and then before you put them in the major table that you will report them, you can already you can take notes. Okay, sige, so let's move to the next, so let us answer the question. Is sex related to or associated with social media? No, social media competence. Okay, so let's do that. So how do we do that? We go to t-tests and then go to independent samples t-test. All right. So let us look at our, so in the dependent variables, you can already put the 4. No, so you can, the JAMOVI will be able to read them together. So technical usability, content interpretation, content generation, anticipatory reflection. And then the grouping variable is the dichotomous variable that you will have. Now, remember that it will only read the dichotomous variable. If you put here a grouping variable that has more than 3 groups, it will have an error. For example, if I put income ID, error. So it must only have it must only have 2 levels. No, so we put here sex. So it will now read. Okay, so we can. What is important is you also sorry, you have to see here that the check here, it's already a default is students t-test or the independent t-test. And again, this is the parametric. So number 1, what we need to do is same thing that you did here. Look at the p-value, no, but this one does not have an asterisk. So you really just have to look at the p-value. Okay, if the p-value is less than 0.05, then you reject the null hypothesis. Then it's significant correlation. Those that are equal or greater than 5, it's not a significant correlation or significant association. Or some of them would say significant difference. Okay? Ibig sabihin, the social media, the particular social media domain is significantly different when grouped according to males or females. All right. So you see here the p-values, and you see technical usability, the p-value is 0.1. So no, it's not significantly associated. So there's no, we fail to reject the hypothesis for technical usability and sex. For sex and content interpretation, the p-value is 0.546. So no, we don't have also. And then for content generation, look at the p-value, it's 0.008. So it is significantly associated. And anticipatory reflection, 0.002, it's also significantly associated with sex assigned at birth. But the next question is, who is higher? Is it the males or the females? And how do we get that insight? You know, you examine the mean and SD of each category. Okay? So how do we now get that? Descriptive. Okay. So of course it will, regardless whether you have rejected or not the hypothesis, whatever you placed in this command, they will generate. Okay? So they generated technical usability and content interpretation, but we will not investigate that bucket because the p-value is not less than 0.05. So we will only investigate technical usability, content generation and anticipatory reflection. So you have your female versus male, you have the number per male and female, and then you have here the mean, and then you have the SD. And as you can see, the mean for the females is higher than males for content generation. So females have significantly higher levels of content generation. And anticipatory reflection was 3.84 versus 3.72. So females have significantly higher levels of content generation and anticipatory reflection compared to males. This one, yes, you can see that the mean is higher for females than males, but it's not significant, meaning the difference that we see here can only be attributed to chance and may not really be influenced by the independent variable, which is sex assigned at birth. But again, what we're looking at here is a t-test, and for you, you have to do a non-parametric test because you use convenience sampling. So we are going to uncheck this, and we will check Mann-Whitney U. So when you look at the Mann-Whitney U, the findings are the same. No, you just have a different statistic. No, so earlier for the student t-test, this is the t-value. Right? Itong 1.616 pababa to 3.076. But for man with mu, it's actually a whole number with a lot of numbers. So that's your U value. You report this. But what is really important is the P value. So the same thing, content generation and anticipatory reflection. And it's still the females, and the females are higher significantly for content generation and anticipatory reflection. Okay, so that is for doing your so this is for dichotomous, relating it to continuous variables. Now let's go to multichotomous variables, whether they're ordinal or categorical, and how they're related to continuous variables. And for example, income level versus the DVs, no? And so let's go to ANOVA. Let's click one-way ANOVA. So let's look at one-way ANOVA. So let's do this. Wait, I can't see it. So let's choose pa rin, no? Technical usability for the dependent variables, content interpretation, content generation, and then anticipatory reflection. You have it here. All right. And then your grouping variable, no, is I will put here income ID 127. And then we will be able to see that the p-values for so the same thing, no, we copy. For step 1, we look at the p-value. If the p-value is less than 0.05, no, then there's a significant association or difference. Number 2, for those that are significant, run a post hoc analysis. So the post hoc analysis will tell you, okay, the post hoc analysis will tell you which among the many groups have significant difference. So for example, you have 7 groups here from poor to rich. So which among them have are really different, no? So we just know that somewhere among those groups there's a difference that can be seen. So which among these groups are different? So let us investigate. So usually the first thing that we can do is we can do a descriptive table. The descriptive table will give us the mean and SD for each group. All right, but that won't give us so much insights. We can go back to that later, and we go to post hoc test. And the usual post hoc test that we use is 2-key test or 2K test. I don't know how it's pronounced. All right, so usually what you will find here is that there is a group 1 versus group 2, group 1 versus group 3. So parang nag-round robin siya. Group 1 versus group 4, group 1 versus group 5. And then what you will investigate here is, no, investigate the cross sections with p-value less than 0.05. And those cross sections is where we find the difference. So for example, when you investigate group 1 versus group 3, group 1 versus group 4, group 1 versus group 4, 5, 6, and 7, all of the p-values are less than 0.001. So that's less than 0.05. So it means that there's a significant difference between the poor versus the middle income and high income groups. Now, how do we know who is higher? So you look at the sign of the mean difference. If the sign of the mean difference is negative, it means that this one in the left is smaller than this one in the column, right? So it means that the mean of poor respondents is significantly lower compared to lower middle income, middle income, upper middle income, rich, high income but not rich and rich. And how do we, and then this is only for tech usability. You can also investigate for content interpretation. It's actually the same also. 2, 3, 4, 5, 6, 7, andito yung p-value na less than 0.5. All of them are negative. So poor respondents lesser compared to the upper ones. So let's investigate for content generation. Same thing. you have group 4, group 6, and group 7. Group 1 is significantly different than them, but you can actually kind of interpret this as a pattern, as richer, that poorer participants are more likely to have lesser content generation scores. And then this is also goes to the same for anticipatory reflection. So versus 4, versus 6, versus 7, the value is negative. And you can, to confirm your insights, you can look at the means here. So mapansin niyo yung mean ni 1 ng poor participants, it's definitely lower compared to the rest. 3.87 and the rest are at 4. 3.51 and all of them are higher. 3.67, all of them are higher. So it gives you, this first level gives you an idea whether or not there is a significant difference within the group. But this one gives you the idea or the insight which among those groups are significantly different, and then you're trying to investigate the pattern. So in this case, it appears that the pattern is that for all domains, poorer respondents or the poorest respondents are more likely having less social media competence compared to their richer counterparts. Okay? But this is one-way ANOVA. We cannot use this, especially if your sample size is small and you cannot assume normality. So we're going to use a parametric test, a non-parametric test. And the non-parametric test is Kruskal-Wallis. This is a little bit trickier. So I hope that you follow me well, because this is what you will do if you have a multicotomous variable. So we go to ANOVA, we go to the non-parametric, one-way ANOVA Kruskal-Wallis, right? So you do the same. So we put income ID here, and then we put the 4, tech usability, content interpretation, content generation, and then anticipatory reflection, right? And then the same thing, the p-values, ibig sabihin, the meanings are the same. Now, so same thing, no? You investigate, I just copy here so that you don't forget. So look at the p-value. If the p-value is less than 0.05, and then if not, you also, dapat kinapi-paste ko na rin. For those that are significant, run a post hoc analysis. Sir, what if hindi siya significant? There's no significant difference. The p-value is not 0.05 for any of the components. Then you don't have to run a post hoc analysis anymore because it's not significant. Okay? So you don't have to do a post hoc analysis if it's not significant. It just so happens that for this particular, it is significantly, they're all significant. So and then post hoc analysis is the DCSCF pairwise comparison, and the Dwas, Steele, Trichlow, Fligner pairwise comparisons. I do hope that I didn't butcher those names, but what you do here is that you examine or you investigate again which pairs have the p-value that is less than 0.05. And you see here 1 versus 3, 1 versus 4, 1 versus 5 and 6 and 7. They're all less than 0.005. So you can kind of say the same thing. However, this will not give you, I'll do the same for content interpretation. Same thing, the 0.001, same areas, no? And then this one, for this one, it's only 1 versus 7, the richest versus the poorest. Okay, so you see really the one that's disadvantaged is the poorest. And then here, also the richest versus the poorest. Yun yung nakita natin. So again, you investigate where the p-value is significant and those pairs are significantly different among the rest. Now, the problem in this particular area is that it doesn't give us like significant means. So where do you get the means? So you get the means in exploration, you go to descriptives, and then you put the variables of interest. So where do you put the variables? Where are those? So the variables of interest are, so let's put them again here: technical usability, content interpretation, content generation, and then anticipatory reflection. Put them here, and then you just split it according to and then put this according to rows. Let's remove the median, the end, the missing, the minimum, the maximum. Let's just leave the SD and mean. And then let's split it according to income ID. And you have this. Okay, so this is your mean, just to give you more idea. Okay, so 1 to 3 to 1 to 7 is significantly different. So who's higher, who's lower? You go to the mean. So now we see that the mean of those in the poorer population are lesser or significantly lesser compared to their richer counterparts. Okay, so this is how so it's trickier when you have multicotomous variables actually. So sometimes statisticians, if they can transform to dichotomous variables, so you can just imagine if this was like that. That's the reason why I'd rather work with LGBTQ versus cis heterosexual versus all of the sexual orientations, because you have to go through this. But if only just two groups, then you just have to do two t-test or man with mu like this one. Okay? Sige. All right. So those are for so I will not be teaching you anymore for the paired t-test and the repeated measures ANOVA, because most of the tools that we're usually doing a cross-sectional study anyway in our department. So we may not be able to do it, no? So I'll just teach you for those who are maybe I'll just give an example of what will of when it's not correlated. So let's say let's go again to one-way ANOVA, and probably let's choose one variable that may not be sige, for example, I'll just go here. Go back tayo sa here, no? Sa quantitative interpretation. So this is income ID. What if we change the grouping variable to, let's say, let's choose living arrangement. So in this case, living arrangement has 3 groups. So let's see if it will change, no? So let's see. So as you can see, the p-values, when grouped according to living arrangement, whether they're living alone, living with family, and living with non-relatives, the p-value is greater than 0.05. So because of this, we don't have to do post hoc tests anymore. We just say that it's not significantly associated with living arrangement. Okay? So when do we do a post hoc analysis? When the p-value is less than 0.05. No need to do post hoc if all of the components or all of the continuous variables are not correlated. So I'll just return this back to income ID. Yeah. Okay. So that's all right. So what if we're going to do so let's delete this. All right. So what if we want now to do chi-square? So if we don't have a continuous variable in the pair, they're both dichotomous, or one of them is multicotomous, or they're both multicotomous, how do we treat? Okay. So we will go to, Okay, so we go to analysis. We go to frequencies. You go to independent samples, X-squared test for association. So this is what you will use. And then you will put in the rows your independent variables. So in this case, we wanted the question is sex associated with having depression? That's the basic question here. So we put sex in the rows, and then we put depression. In this case, the name is depression risk. So we put it here. All right. So you have here now a values. Now, what is important here is that okay, so let's put here your percentages per row. Okay, good. And then the first thing that you have to look at is if the p-value is less than 0.05. So if the p-value is less than 0.05, then it is significantly associated. So here it's 0.014. So yes, it is significantly correlated. associated. So, but by the way, if you're using chi-square, you don't use the word correlated, you use the word associated, regardless, because this is a test for association. You cannot correlate two dichotomous variables or two multichotomous variables. All right, so let's move to the next. So, how do we now know who has the higher depression risk? So you have to investigate. 0 means no depression. 1 means with depression. So it means that 45% have no depression, 54% of females have depression. And then you have to investigate the second group, whether or not pababa or pataas siya. So if you move here to the left, the right, as you go to having depression, it goes higher. So ibig sabihin, being female, so for females, the depression goes, the proportions go higher. Naging from 45, naging 54. This one, for males, from 53%, naging 46.7. So we can see that females are more likely to have depression risk, of higher risk of depression compared to males. So this is how we treat them. For 2x2 groups, we actually also can check odds ratio. So the odds ratio will tell us if this is female is 0, male is 1. We see if the value of sex is 1, which is male, and the value of depression risk is 1. What is the odds that males will have depression? So the odd is 0.737. The closer the odds ratio is to if it's less than 1, it means that being male, or the 1 here, has lesser risk for depression, or has lesser odds for depression. For females, it's higher, right? So yeah, that is how we do it. But I don't expect you to do odds ratio. I just want you to, if you're doing contingency tables, if you're doing chi-square, because you have both categorical and categorical independent variable and dependent variable respectively, you just have to look at the p-value and investigate how the percentages in the row, okay, for each independent variable changes as you progress in the categories for your dependent variable. And then you'll be able to see here who is more likely to have 1 or scored 1, in this case having depression, and who is more likely to have more scores for 0. All right, so females are more likely to be depressed, at least for this 1,087 participants that we have. Okay, so I hope that so that is your how we do it in JAMOVI. Now, how do we present? So what would be another way to present this? So this one is one of the ways you can revisit one of the videos that I will show you, but this one I will support. So this presentation, all right, you have the table title, you have your table number, table title, the usual, so I don't have to explain that. And then for the columns, or for the leftmost columns, or for the row, you have the independent variable, in this case your background characteristics, and then you have your social media competence variables here, which is the dependent variable. You only need 1 for each. And then for your background characteristics, maybe we can bold this so we can really kind of visualize. All right, okay, there you go. Okay, so if for those pairs that you need Spearman-Rowe or Pearson-R, for example, age and social media competence, number of gadgets and social media competence, number of social media accounts and social media competence, you will include 2 extra rows. Those extra rows are R value and P value. And then you report the R value and the P value. And that's simple. Okay? So for example, in this case, let's look back. All right? So yeah. So for age, you have negative 0.24, 0.44. So you can see how it happened here. All right. So I just wrote the R values here, and as you can see, this is the first values in the right side in our data set in our JAMOVI, and then I wrote the p-value. You can see I didn't put any asterisk because again, none of them are significantly correlated with each other. Okay, how about, and then for number of gadgets, look at the intersection, so they're all significant. Now, if the value of the p is less than 0.0105, it's 1 asterisk. If it's less than 0.01, 2 asterisks. If it's less than 0.001, 3 asterisks. So just to say how lesser the probability of error is. Okay? So here I have the 2.91, 222, 106. So if you investigate, you can pause the video and investigate where I got these values from. Here in the right side, 2.91, 2.222, 176, 160. Oh, I was wrong. This is supposed to be 1.43. See? Signs of aging chart. Okay, and this one is 165, 146. And this one is supposed to be, why is this 143? Tama. So this is, sorry, this is 176. Signs of aging talaga. All right, sorry. Okay, so, and then I wrote here less than 0.1. Where did I get this from? Here, the p-values in this. So I used Spearman rule. So you have the R value and the p-value. That's for Spearman rule or Pearson R. How about for independent t-test or Mann-Whitney U? So you have the U value and the p-value and the mean SD of your of the two groups. Okay, so usually what I do is like indent just to kind of say that this is under this particular variable. What is good about this presentation versus this presentation is that it's good to accommodate when you have more than 2 or more than 3 categories of or components or domains of the dependent variable. So this one has 4. Imagine if I am going to fit the 4 here, it's going to be very messy. So I just did this so that everything is going to be seen vertically. So if you would investigate now, here you have the p-value, you have the u value here, so 131,180, 13674, etc., etc. I placed 2 asterisks here because the p-value is 0.001, and then 3 asterisks here because it's less than 0.001. Where do you put the asterisks? Not in the p-value. You put it in the statistic of the statistical value, no, the generated statistics. In this case, u value. If it's Pearson, if it's independent t-test, this is going to be t-value. Okay, next, you have to report the mean and SD. So usually what I do is that I put mean plus minus and then the SD. And then you put the name of the category. So this one is the male level and the female levels, and you can investigate, the means, no, and the SD are placed here so that the researcher or the reader can visualize already who is higher and who is lower. And then I did the same for household income. So for household income, so let's look at my, so this is my Kruskal-Wallis. My X squared is here. All of them are less than 0.001. So I reported my X squared. I reported the p-value here at the next for each, no, on in there accordingly based on the component. And then so of course you have many rows here because I had to accommodate 7 categories. And where did I get this? I got this from this. All right. Okay. And I'll just have to report so the researcher or the reader can already have an idea of how, how they are. Okay. So there you go. Oh, wait, I did something wrong here. This is supposed to be, so you can probably just correct this, no? 3.77 should be for the ones that are poor, right? Kasi, nagkabaliktad. Kasi yung pinakamataas ko was rich. So, anyway, So I'll just move it, no, or you can just move it, no, or anyway, you just have to ensure that that they are correct. No? So I just deleted it, no. Wait, let me just pause share and pause recording and allow me to do it. Wait. There, I have already corrected it. So yeah, so these are the values. When you look at your the descriptives here, so the mean and SD, so pinagbaliktad lang, it just got reversed because I started here with the rich and then ended up with the poor. And then you have here the actual data. All right. So this is how you will now present if it is. Now this will be the F value, no, if this is. So now how do you do textual explanation? So the textual explanation, one paragraph, no, one paragraph per domain of the dependent variable. So let's see. So we start here. Bivariate statistical tests were used to test the significance, examine maybe, or determine the significance of the relationship between background characteristics and social media competency table, whatever number table it is. The technical domain of social media competence. And then you investigate which one is correlated or which one. So it's correlated or it's associated with household income, number of gadgets, and number of active social media accounts. Okay, so let's see. So social media competence was significantly associated with household income, right? And then based on our testing earlier, post hoc analysis, and then you have to write, you have to write the x squared value, and like here in the lower, no, what is the x squared value and the p value on the test statistics, no. So in this case, it's 7.78.2. You know, you may notice that the way I spelled x squared, p, r here, they're all italicized. So the how do you call that? No, the label or the letter used, no, to identify the value of a statistic has to be italicized. So 7.8.2. And then post hoc analysis based on the patterns that we see. No, tests reveal that respondents, no, from poor households had significantly lower scores for technical usability. And moreover, furthermore, what do we say pa? So it's also correlated with, so if there is one domain in the independent variable that hit or is significantly associated with the dependent variable, you only report those. No? So let's go with number of gadgets. No? So let's just copy paste here. Sorry, let's copy paste so that we just have a guide. Okay. All right. Furthermore, students who had more gadgets owned, and then we can write here the R value. So R equals 0.291, and then the P value, P is equals to less than 0.001. And maybe we can already append this to the sentence, and active social media accounts. We have R equals 0.233, and then P is less than 0.001, scored higher in technical usability. And then a new paragraph for the next. So moreover, the content interpretation domain of social media competence was significantly associated with household income. Post-hoc analysis tests reveal that respondents from poor households had significantly lower scores for content interpretation. Meanwhile, content interpretation was also found to be significantly higher among students with more gadgets owned and social media accounts. And then you put here the value. So I will give this document to you and you can investigate. Okay. And then you have here your a sample of table 2. So I will not do this anymore, but look at the independent variable in this question is social media competence. So we move technical usability, content interpretation, etc. here. Since we're going to use Spearman here, the R and the P value are placed under each domain. And then the domains for the dependent variable, which is social media political participation, are also found here. And then you're going to interpret this. If this is, of course, you're not going to do this because this is my data set. You're going to use your own data set. So you are going to do one section of text with table per hypothesis. So most of you have at least 3 hypotheses. So I expect 3 tables with 3 textual explanations. So the textual explanation, you have the heading, which of course gives us a clue of what the hypothesis you are testing is. And then you also have your textual explanation and then the table complete. So sir, what if hindi siya correlated or hindi siya significant, no? And then you just report, for example, hindi significant. So, for example, let's say the domain blank of the blank variable was found did not yield any significant associations with then the name of the other variable. Ganyan lang, no? So ibig sabihin, all of the p-values were higher. And some of you might have those kinds of findings because you might have a small sample size, so there's a more tendency to get a false negative, right? So you have to do. So do you need to submit? So first you have to submit this table. Write your inferential questions in the hypothesis, no? So each hypothesis, or you can write the hypothesis. So each hypothesis, IV, DVs, and then ano yung gagamitin nyo. And then stick with non-parametric here in this table. Okay, so I expect that there are 3 major parts, no? Hypothesis 1, hypothesis 2, hypothesis 3, IV for each, DV for each, and then write in open and close parentheses kung anong type of variable siya, and then ano yung non-parametric test na gagawin ninyo. Okay, so that is what you will place in your assignment, and then following that, you have the subheading, you have the report, and of course, in your case, you're going to do this APA style, so double space ito. I just didn't put this in double space so you can see it in the video that I'm sharing now. And then, of course, you have your table 1. And, of course, you have to make this APA. So, of course, let's make this APA. Wait up. So, let's remove the unnecessary lines. And we only keep the lines that we need. So, no border. And then we have the top border, bottom border, and then the bottom border, and then also the bottom border here. Yeah, so that's how it just looks. Okay, and then you have the note here that says which p-values, no? So this is how it should look like. All right, so that was a long explanation. We covered all of the bivariate statistics and how to present them. So I hope that you're guided for your particular research works.